Have you ever found yourself staring at the night sky and wondering what lies beyond the universe? It's a question that has sparked curiosity, fascination, and intrigue in the human mind for as long as we've been able to gaze up at the stars. The vastness of the cosmos, the twinkling galaxies far beyond our reach, have always provoked a sense of wonder and an insatiable thirst for understanding. The universe, with its magnificent galaxies, countless stars, and infinite celestial bodies, is a grand spectacle that has left us in awe. But it is also a source of profound mystery. What are its boundaries? Does it have an edge? And if so, what lies beyond it? These questions have puzzled some of the greatest minds in history, from ancient philosophers to contemporary scientists. They've ignited fiery debates, inspired countless theories, and pushed us to the very limits of our understanding. It's not just about scientific curiosity either. This question touches on some of the most fundamental aspects of human existence. It's about our place in the cosmos, our understanding of reality, and our quest to uncover the ultimate truths of existence. It's a question that transcends science, spilling over into philosophy, religion, and the very core of human thought. But to even begin to tackle this enigma, we must first grapple with another question. What exactly do we mean when we say the universe? Is it simply the sum of all matter, energy, and space-time that we can observe? Or does it encompass something more, something beyond our current understanding? It's a concept that's both simple and staggeringly complex, both familiar and utterly alien. So as we embark on this journey of discovery, let's start with the basics. Let's delve into the very fabric of the cosmos, peel back the layers of reality, and try to make sense of the universe we inhabit. Only then can we begin to ponder what, if anything, lies beyond its boundaries. To tackle this mystery, we first need to understand what we mean by the universe. So, what exactly is the universe? Well, when we talk about the universe, we're referring to the grand totality of everything that exists. It's the complete collection of all matter, all energy, space, and time itself. Picture the most distant stars you can imagine, the deepest oceans on the farthest planets, the vast emptiness of space, and the ticking clock of time. All of these elements come together to form the universe. Now let's take a moment to grasp the scale of the universe. It's so vast that we often use the term cosmic to describe its size. Imagine if you could travel at the speed of light, which is about 186,000 miles per second. Even at that speed, it would take you over 2 million years to reach Andromeda, our nearest spiral galaxy. Yet, despite its vastness, the universe isn't static. It's ever expanding, growing larger and larger with each passing second. This isn't a simple stretch like a balloon inflating. Instead, it's the creation of new space, new parts of the universe coming into being. But here's a rather interesting point to ponder. The universe, as vast and infinite as it might seem, doesn't have a center or an edge. It's not like a ball or a square where you can point to a middle or an outer limit. The universe is all there is, and it's everywhere. It's like if you were standing on the surface of a balloon. No matter where you stand, you're always in the center. So, with this understanding, the idea of something being outside the universe starts to become a bit tricky. Because if the universe includes everything that exists, then by definition, there can't be an outside, can there? It's like trying to step outside of existence itself. As we delve deeper into this topic, we'll explore why this question is so complex, and why it continues to baffle even the brightest minds. Now let's try to wrap our heads around the concept of outside the universe. To start with, we need to understand that the word universe by definition includes everything that exists, all galaxies, stars, planets, and space-time. So the notion of something being outside the universe is in itself a conundrum. It's akin to asking what's north of the North Pole or trying to find the edge of a sphere. There's simply no outside in the way we usually understand it. The modern cosmological perspective further complicates the idea of an outside. Current theories suggest that the universe is finite, yet boundless. Imagine you're walking on the surface of the Earth. You can keep walking indefinitely, but you'll never find a sign that says end of the Earth. This is because the Earth, much like the universe, is finite, but unbounded. This concept can be a little tricky to grasp, because our everyday experiences are confined to a world with boundaries. But in cosmology, boundaries are not a prerequisite for finiteness. The universe can be likened to the surface of a balloon. As you inflate the balloon, the surface expands, but there's no boundary or edge. Now you might be wondering, if the universe is like the surface of a balloon, what about the space inside or outside the balloon? Well, remember, this analogy only considers the surface of the balloon as the universe. The inside or outside of the balloon is not part of this model. So while it might be a tantalizing thought to imagine a realm beyond the universe, the reality is that the concept of outside the universe is a problematic one. It doesn't fit into our current understanding of space and time, and it doesn't align with our cosmological models. So, if the universe has no boundaries, can there really be an outside? Well, as far as our current understanding goes, the answer seems to be a resounding no. But who knows what future discoveries might reveal? After all, the universe is full of surprises. What do the laws of physics have to say about this? Let's dive into the realm of physics, a science that has shaped our understanding of the universe. Physics gives us the laws and principles that govern the cosmos, from the smallest particles to the most massive galaxies. So what does physics tell us about the concept of outside the universe? Let's start with Einstein's theory of relativity, one of the pillars of modern physics. This theory revolutionized our understanding of space and time, merging them into a four-dimensional framework known as space-time. According to this theory, space-time isn't an empty stage on which the universe unfolds, but is intertwined with matter and energy, curving around massive objects like stars and galaxies. But here's the catch. The theory of relativity applies to the universe, to everything that exists within this space-time fabric. It describes how matter and energy interact with space-time, but it doesn't provide a context for what might lie beyond it. In other words, the laws of physics, as we understand them, are confined within the universe. They can't tell us about an outside because, by definition, they don't apply there. Take gravity, for instance. It's a fundamental force that structures the universe, pulling matter together and shaping galaxies, stars, and planets. But if there's no matter or space-time outside the universe, what role would gravity play? Without these elements, our understanding of gravity, or any other physical law for that matter, becomes meaningless. In essence, our existing laws of physics are like a language. They allow us to describe and understand the universe, but they can't articulate what's beyond its bounds. It's like trying to describe colors to someone who has only ever known black and white. Without a frame of reference, the task becomes impossible. The laws of physics as we understand them don't seem to allow for an outside. So where does that leave us with our original question? We've journeyed through the vast expanse of the universe, grappled with the concept of an outside, and probed the laws of physics as we know them. Yet we find ourselves back at the starting point, still pondering the enigma: what exists on the side of the universe? The universe, in its definition, encompasses all that exists: galaxies, stars, planets, and the very fabric of space-time. So the notion of something outside the universe is inherently problematic. By definition, there would be no space, no time, no reality beyond the universe. It's akin to trying to find the outside of a three-dimensional sphere. It simply doesn't make sense in terms of space and time. Our current cosmology suggests that the universe is finite, but without borders or boundaries we can identify. A seemingly paradoxical concept, yet it's what we work with. And then, there are the laws of physics, the rules of the game. These laws, such as those of relativity, apply within the universe and don't provide a framework for describing what could be beyond it. So what exists on the side of the universe? It's a question that remains unanswered in current science. It's a question that challenges our understanding of reality and pushes the boundaries of our knowledge. It's a question that perhaps is beyond the scope of human comprehension. But the beauty of science lies not in having all the answers, but in the relentless pursuit of them. This question, complex and challenging as it may be, continues to fuel our curiosity. It drives us to explore, to learn, to push the boundaries of what we know. While we may not have a definitive answer, the quest for understanding what lies beyond the universe continues to fuel our curiosity and drive scientific exploration. The universe is vast and mysterious, and there is so much more to discover. And in this endeavor, every question, answered or not, brings us one step closer to understanding our place in the cosmos.